Thanks everybody for having me. I'm Doug Sillars. I'm originally from Seattle in the United States, but I've been traveling with my family for the last 2 years through Europe. And today I'm excited to talk to everybody about fast and beautiful images and how to optimize your native app. I'll talk a little bit about the web because that's easy examples. Ways to optimize your site for when it's just too slow. So a little bit about me. I do freelance developer relations. I help people with performance audits. So I help fix apps, native web, and I do workshops to try to help make the web and make native apps run faster. I run workshops and stuff on sort of what I'm going to talk about today. If you're interested, I wrote a book called High Performance Android Apps, and that's a link to the PDF. So if you want to download it, you're more than welcome to check that out. And if you ever have any questions about performance or anything about how to speed things up, I'm the only Doug Sillars on the internet, so I'm really easy to find. Before we start talking about performance, how many of you, when you look at this picture of a walkway nailed onto the side of an Alp, get a little nervous thinking about walking across it? Anyone? Hands? There are a few hands, right? It's literally nailed into the side of an Alp, and when I walked across this with my family, my 6-year-old decided to jump across the whole thing, and so it wobbled, which added a little bit to the ambiance to the whole thing. About 2 years ago, Ericsson did a study, and in this study, they put sensors on people's heads to measure stress responses to different activities, and they found that standing in line made people feel a little bit stressed. They found that standing on the edge of a cliff really stressed people out. But interestingly, they found that a slow mobile experience is actually more stressful than standing on the edge of a cliff. And so if we build apps or we build websites that are slow, our customers are stressed out when they're using them. And typically when people are stressed out, they're not happy, they don't come back, reuse it, they don't buy as much stuff. And so if our goal is to have people use our application or buy stuff with our application, this is not the way we want to be going. So often when I start saying if your site is slow, that's a problem, the next question that comes up is, what's fast, right? It's a human perception, and it can vary depending on what people think. And so 100 milliseconds is perceived as instantaneous. And that's actually a 100 millisecond delay as that feeds across the screen. So if you have a delay that's 100 milliseconds, people generally don't care. But what about 1 second? You know, you saw that delay, right? You didn't have time to think about anything else. You noticed it, but it was cool. But what about 10 seconds? Did I turn off the iron? Did I pay the mortgage? Right? You start thinking about other things because you're waiting so dang long for the page or the app to load. You lose your focus and you start doing other things, and you might just abandon the task that you were taking on. Now, what's interesting about the study that presented this is it was done in 1993. And now if you think about the web in 1993, how many of you remember Mosaic? Right? All right. How many of you were alive in 1993? All right. I remember Mosaic. It was awesome. The other thing about surfing the web in 1993 is it was slow, right? And so 10 seconds was slow and frustrating people when they're on a 28.8 modem, right? So you might argue that 10 seconds isn't accurate anymore. It's probably more 3 to 5 seconds before people start freaking out that things are taking too long to load. Interestingly, it's not 100 milliseconds for instantaneous. This research just came out in a blog post on the 5th it's actually 65 milliseconds, and as you might imagine, it's a range. So some people, if it was over 34 seconds, it wasn't instantaneous. If it was 164 milliseconds, it wasn't instantaneous. And it varied, people who play a lot of video games really want it to be even on the low end, and people who don't play, it's just interesting. And that blog post came out on the 5th. So this is rapidly changing, and people are coming up with new ideas of where all this stands. But there is actual data out there. Google found that a 3-second delay causes 53% of your users to abandon a mobile website. A half-second delay makes your customers more frustrated and less engaged. A classic study that's almost 20 years old now Both Amazon and Walmart independently found that 100 milliseconds causes them to lose 1% of their revenue. And you start thinking about that, that's a lot of money. And then my favorite study is 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So when you're on the subway and you see someone with a cracked phone, hopefully that's not because of your app. So what are we going to do to look to see what we can do to optimize these apps? So the tools I use are Charles Proxy. I use web page test for the mobile web. And I use Video Optimizer, which is a tool I helped build when I was at AT&T to look at apps. Even though it says video, it's for apps as well. So when you do Charles Proxy, you're running a proxy between your phone and the server, and you can see all the connections. You can see everything that's downloaded. You can see the headers. You can see the content. Video Optimizer is very similar. You can see all the packets going back and forth. The red line is showing you the throughput, so you can see when a lot of stuff is being downloaded. You get a lot of information about what's being downloaded, and so we can see what's happening and how to fix it. Video Optimizer goes a step further in that it actually grades the content that's being downloaded against 40 best practices. So a green check mark means you're doing a good job. A red X means we'll show you how to fix that. For example, here's a failure on resizing images for mobile. And you can see there are a bunch of images that are like 800 kilobytes, 1.1 megabytes. And they're just huge. And that's obviously going to take a long time to download. If it takes a long time to download, it makes your app slow, right? The next app that I use is Web Page Test for the mobile web. If you build websites, you should use this to profile your application. You can test your site all around the world because there are different locations. You can test on mobile devices. And you get results like this with all sorts of different timings. And we'll talk a little bit about what the waterfall chart means as we go through this talk. So we've got these great tools to profile. So let's get started. And so you pull out your phone, you hook it all up to your laptop. And there are a couple things that are immediately you need to think about. And so if you're testing in your office, you're probably connected to a really fast Wi-Fi connection, maybe 4G, right? Everything's gonna be super fast. But that's not testing for the general population. What about your customer who's out on a mountain, right? And has really low coverage? If you're only testing on a really fast connection, you're not seeing what their experience is. So you should see what it looks like on a slower connection. If we start looking around the world for 4G availability and the speed of 4G, Russia is somewhere around 15 megabits per second on the bottom and about 70% availability on the y-axis. The US is about the same spot on the x-axis, but a little higher on the y-axis. But sometimes that doesn't even matter, because this is my phone a couple of months ago when I was in Ireland, and I had 4G, but I had 0 bars. So nothing worked. Like, I'm trying to get directions from the airport to my Airbnb, and I couldn't, right? So network coverage is really variable, and when you're testing, you should make sure that you're testing on a slower connection. And so when you do this, all of the tools that I mentioned have the ability to standardize the connection. So what I generally do is I test on a 3G connection. That way, if your app is fast on 3G, it's going to be fast on 4G, right? So make sure that it's fast for the people on slower connections, because there are a lot of people out there on slower connections. The next thing I want to talk about is the devices that you're testing with, right? A lot of us here have really nice devices in our pockets. I was watching everybody, in the room, as we're checking in, looking at Twitter and everything. We've all got really, really nice devices. If you start looking at the most popular phones in Russia, right, it's mostly iPhones. There's one Android at the bottom. But if you look, some of these phones are really old, right? And really old phones tend to be a little bit slower, right? If you start looking, 50% of phones in Europe are a year or two old. The other 50% are pretty old. And as you probably all know, older phones are slower, right? Older hardware, older software. This is some research from Akamai finding that year over year, websites load 20 to 50% faster just by getting the new hardware. So if you're testing on the phone you just picked up 2 months ago at the store, right, you're going to get a really fast experience. But most of your customers don't have that hardware for that great experience. And then you might be thinking, well, it doesn't really matter because everyone's going to get new phones eventually. But there are a lot of really low-powered phones that are coming into the market today. The Android Go devices, They run the most recent version of Android, but this review for the Alcatel One X is really telling. It's a huge compromise in every issue, in every sense, including price. And I really like, it's got great battery life, mostly because you don't want to use it as much. That's the review, right? So these devices are slow, and they're not, they actually, it's a new device, but you can't rely on new devices to be fast. If you start looking about where Android Go is going to come out, the United States is number 2, but Russia is number 4, right? So there are going to be a lot of Android Go devices coming out. We need to make sure that we're testing on slower devices so that we know that things run fast. So in general, I recommend like a mid-range device, like a Motorola G4, and then you should just go out and get one of these Alcatel One X's or a similar Android Go device. They're pretty cheap. They're pretty easy to get a hold of. So when you're profiling and testing, you should test on a slower network, and you should test on a mid to low range device. And now we can start seeing, is it fast? So let's say you've got a car app for the orange car company, and you profile the load time, and it takes 6 seconds to start up. And you're like, well, is that fast enough? It's hard to know. One really easy way that a lot of companies do is they say, well, how do I compare to the blue car company? Or the purple car company? Or I guess it's green and blue on the screen. And in this case, we're not doing so hot. So what can we do? We need to go in, we need to find some optimizations. We need to fix what's going on with our site. And ideally, you want to be faster or on par with your competitors, because if your competitors are faster, you will lose customers to those people. So what are the rules for speed? In general, most of the content that's slow is stuff that's being downloaded across the network. So we want to deliver the content quickly with faster requests as efficiently as possible. And really, I'm going to talk about images, but video is much the same. They're really big files, and they take a long time to download. I'm not going to talk at all about JavaScript, but that's another thing that you can look to speed up as well. But when an app is starting up, often you get this great splash screen, and what's happening in the background is you're downloading a bunch of JSON, right? That JSON is going to tell the app where to download all the images, it's going to have all the content to populate on the screen. And so the app fires off a GET request. It says, hey, send me the file. The file comes in. This is awesome. But you look at the response, and when I look at this, I see a few response headers that are missing that are really going to slow down the performance of this native application. The first one I see that's missing is content encoding. The file isn't gzipped, right? If you have a text file, you should always compress it. And then I also don't see any cache control, but let's talk about content encoding. So there's this giant JSON file with all the information that's populating that first screen on your page in your app. And in this case, this app I was profiling, it's 267 kilobytes. And, that's good. On a fast connection, that's not going to take very long. On a slow connection, it'll take, it'll be ponderous. It'll take a little bit of time. Just by turning on gzip encoding on your server, you get that file down to 42 kilobytes. That's 85% smaller. It's going to download way, way faster. Many fewer round trips. You're going to speed up the delivery of your content. And because that JSON is where all the requests for the images come from, you're going to get the images faster. It's sort of just a cascading effect. If your file's static, you can go with Brotli, which is another compression algorithm, and it squeezes out a little bit more, another 4% of savings. You're down to 30 kilobytes. That might be another round trip. You may save a couple hundred milliseconds just by doing that alone. The other header that I see missing is the cache control header. And why is that important? So you got the app, it's populated that home screen, right? The images haven't come in yet, but you can see the headlines are there. The problem when you don't cache it is when you go and read an article, you download it, and then you go read an article and you go back to the main page to go to read a second article, it downloads that 267 kilobytes a second time. You read an article, you go back, it downloads it a third time. You can see in this case, I downloaded it 5 times, right? So an extra megabyte download. Just something that should have been cached. So number one, reading from cache is way faster than downloading it, even on a 4G connection. There's data costs that you have to worry about. So if I were roaming on my EU SIM here in Russia, I'd be paying 10 euros a megabyte. So this would have cost me 10 euros just to go back and forth to download the same JSON file a bunch of times. And by simply adding a cache control header, cache this for 300 seconds, 5 minutes, I would have avoided this. You could have avoided this from happening. Now, obviously, every site has different cache times. 5 minutes might be appropriate, 1 minute, maybe an hour, right? That's something that you can decide, but by simply caching that file, you're going to save a lot of time and data and speed up the delivery of the content. All right, so we've got all these images we're going to download, and then you load up the app. And this is a movie app. It's listing all the movies that are in theaters today, and all the images are being downloaded now. We've got the JSON, it's requesting all the images, and the image looks like this. It's a huge image. It only needs to fit right there, right? So you're downloading this giant image that then has to be resized. It's a giant thumbnail. It's 470 kilobytes. And when I resize it to about the size that it shows up on the screen, it's 3 kilobytes. Now, what's going to download faster? I mean, this isn't rocket science, folks, right? It's going to download. The one that's 99% smaller is going to download a lot faster. So you should resize your thumbnails so that they download quickly. It populates that whole screen faster. People are happy. Let's talk a little bit about what happens inside your device when you download a huge file. So I like showing pretty pictures. So this is Porto, Portugal. I took this with my phone. It's 2.23 megabytes. It's 16 megapixels, right? Because that's just what my phone does for me. And if I want to download that onto my phone, I have to download 2.3 megabytes of data. Obviously, that's a huge amount of data. I don't recommend you do this in your native application, but you could. It's 16 megapixels. But my phone screen doesn't have that resolution. So the CPU has to fire up and resize the thing to 1 megapixel, which is obviously going to be time consuming and take time. And it's really wasting 15 megapixels of the data, right? It gets downloaded and thrown away immediately, even before it shows up on the screen. And the best analogy I can come up with this is like when I order something from Amazon and you get a big giant box. That's my dog Max in the background. And then you open it up and it's empty. There's like one thing in the box, right? We're sending down these giant things and we only need this little tiny bit. And when you do that, the phone has to fire up the processor, and this is in the Chrome browser. You can see on a 3G connection, it takes about 14 seconds to download this image, desktop Motorola G4 mid-range device, or the Android Go Alcatel 1X. But the image decode, right, throwing away that 15 million pixels, takes almost another 800 milliseconds on that low-powered device. So it's that secondary taxation, right? It's adding almost another second to decode the image to put it up on the screen. That can be really expensive. So we really want to optimize our images so that they get downloaded quickly. We don't have to deal with that long decode time, and it shows up on the screen quickly. So let's talk about sizing, right? If I resize that image, like you can't tell a difference. It's the same image, except for it's only 1,400 pixels wide now. I've just resized it so that it fits a typical screen a little bit better. And then if for smaller screens, you can go even smaller. You can go to like, 80 kilobytes, right? Just 800 by 600, right? It's the same image, it's just smaller. It fits the screen better. And it's really hard because there are a lot of Android devices out there. These are all the Android devices that hit Akamai in one day, right? And the color of the box, the size of the box is how many devices. The color is how fast the CPU is. So you can see there are a lot of devices with very low market share, but are really, really slow. And so on the web, what we all do is we build responsive sites, and we build a whole bunch of different images, and you serve the right size image depending on the screen size, right? And so if you correctly size the image, you go down, and so I'm using a 1.5 megapixel image here. You can see that A, the download time is way faster, and that the image decode is sped up a lot too, because there are a lot fewer pixels to throw away and to be decoded and to throw up on the screen. So we're really speeding up the delivery of this content. But we can still do better. The next thing we can do with images is to optimize the image quality. So what I mean by image quality is when you reduce the quality, it's a lossy compression. So we're reducing the quality of the images. You're removing pixels, right? So you lose resolution, but in general, you can remove a lot of the pixels before even the human eye can notice. Google recommends you go with 85% quality, and no one will know the difference. So there's the 85% quality. Or no, that's even more. So you can go too far, right? If you go too far, the image looks horrible. You don't want to do that. So you want to find that sweet spot. 85% from Google is usually fine. But you can actually usually do a little bit better. There's a bunch of algorithms that look for that limit for the human eye's perception. And one of them is called structural similarity. The quality is adjusted to the limit of what our eyes can actually see. You can't tell a difference with the image. It's exactly the same image. And when I do that, and I did this with a tool called Cloudinary, and the URL is right there at the bottom of the screen, I save another 40 kilobytes, right? So it's going to download even a little bit faster. We can see the decode time went up a little bit, but the download time is so much faster. Some of this is just error in my measurements. It was completely not scientific. But you can see I'm still speeding up the download time overall. The next thing I'm going to do to optimize my image is look at the image format. If we look on the web at the image formats that are out there, it's mostly JPEGs, PNGs, they're GIFs, some that have no format at all, 11 million that don't list the format. But if we start looking at the different sizes, the largest images that are out there, this is from the HTTP archive, are JPEG without the E and JPEG with the E. But if you look, there are other formats that are a lot smaller. For example, WebP is about half the, in general, about a little more than half the size of JPEG files. And if you look across browser support, it's gotten a lot better. Just in the last 6 weeks, we've added Firefox and Edge to supporting WebP. So WebP support is very, very good. If you're an iOS developer, you've got JPEG 2000, which gives you much the same results. So if you're doing iOS or Safari, you can do JPEG 2000. If you're doing the other browsers or Android, you can do WebP. And when you save that file in that format, you save another, I think in this case, about 20 kilobytes. So we've gotten this file down from 2.2 megabytes to 160K. And again, it's downloading a little bit faster. The image decode is even getting faster. And you can see we've really sped up the delivery of this one image just by taking it from full-size image to resizing it to setting the quality and setting the format. Another image format that's really useful that people should look at are scalable vector graphics. And if you look on this chart, they're the smallest on the list, right? They're right in the middle. They're super small. And the reason they're super small is they're XML files. You're just drawing images as shapes. They're infinitely scalable. And you can add them inline to your HTML, and they look the same no matter how big you scale them. You have to be careful with vector graphics. This is a website that I found in Brazil. It's using the Facebook logo. And when I opened up the SVG file, I opened up the XML, there was a bunch of Adobe Illustrator stuff in the file. It was actually 1.3 megabytes of Adobe Illustrator stuff in the file. And so I quickly edited it by dragging and deleting and resaving, and I got it down to 900 bytes. That's like 99.99. There are a lot of nines savings here. So it's a great way to build really simple graphics that you can put into your websites. I talked a little bit about caching when it came to the JSON files earlier on, right? If you load a file locally, it's going to load a lot faster than downloading it from the internet. So here's another example with images. So this is an app that I was playing around with, and it's got this image of this guy, this scientist, looking into his microscope. And when you click the article, you get the same image of the guy looking into his microscope, except for it isn't the same image. It downloads 2 different images on 2 different pages that are nearly identical. And the first one is 60 kilobytes, the second one is 30 kilobytes, but if you look at the dimensions, they're essentially the same article, or essentially the same image. Why did we download that same image twice? Why are we storing an identical image on our server twice, right? So we've got storage costs that we're paying for, we've got download costs that we're paying for. This could be very easily optimized by just having one image and referring to it on both pages. They are slightly different. You can see one's cropped slightly differently, but it's not that significant a difference that you need 2 different images for your application. Another huge way to speed up the load time of your app or to speed up the load time of your web page is lazy loading, which means only load the content that your customers can see on the screen at that time, right? So on the web, like this is a web page that I built. It's got a bunch of images, but this is the full web page. right? I've zoomed way out, you can see the entire web page. There's like 6 different viewports here. That's the one that you see when the page loads. But when you load this web page in Chrome today, what you see is eventually, first you see all the text, and then you start seeing some placeholder images. But what you actually see is you see like this image of the cow is loading before the images that you originally see on the top of the page are loading. The images are all loading out of order. And so as a customer, it just looks like your page is slow because they don't know that all this stuff is going on below the fold. They only see the stuff on the screen they're looking at. And it's taking a long time for it to load. What's really cool is browsers are starting to take care of this for us. In Chrome right now, there's an experiment that allows that you turn on lazy loading, and what it does is it takes the first 2 kilobytes of every image, it lays out the whole page immediately, as you can see in column 3, the entire page is laid out, and then you can watch the images load in from top to bottom, which is what we expect to have happen, right? It makes more sense as a customer to have the images load top to bottom. Really, really exciting stuff coming to a browser near you pretty soon. And then the other great thing you can do with lazy loading is you can add preview images. So when the image isn't there yet, put in a preview image. So Google image search today, if you search for cats in costume, as one typically does, you get different preview, just colored blocks saying an image is coming, and then it pops in. But the colors match the primary color of the image that's coming in. So the cat that's dressed up like a dragon gets green, the cat dressed up as a pumpkin gets orange, right? So as a customer, you expect those images to come in. The other great, so this is the same idea with preview images, but what I've done here is I've done SVGs of each of the images. Rather than just a solid block of color, I've got, sort of an idea with a few vectors of what it looks like. And so that SVG is like 500 bytes. It loads in immediately while we wait for that larger file to download. Another huge way to speed up loading of our apps is by fixing our animated GIFs. Now, we all love animated GIFs, but the GIF format is actually really old. It's from the 1980s. And if you read the original GIF spec, it says we have an animated format, but we don't really recommend that anybody uses it. So this is a video of my goat, Nora. And I took it with my phone. It's 1.4 megabytes. And, there's too many cat GIFs. We need goat GIFs on the internet. So here's Nora, and I made it into a GIF. Now, the problem is, when I take a movie and turn it into a GIF, it gets 270% larger. It's now 3.8 megabytes. And the reason for this is because GIF is an older format and just the way it's built. There's no compression through that third dimension of time. It's literally just, if you're doing 15 frames per second, it's 15 GIFs. And so there's no compression. These files get really, really large really quickly. So what can we do instead? Well, if I change that movie to an MP4, or I change the GIF back to a movie, but I make it 256 colors because that's all GIFs have, right? So I'm reducing a lot of the color spectrum in it. And then I remove the audio track because GIFs are silent. I get the whole thing down to 250 kilobytes, which is really cool. And then you can put this into your application, and it's going to download a lot faster than 3.8 megabytes, right? It's going to be super fast to download. And you get that same GIFy sort of experience that your customers love. If you're building this for the web, you can use a video tag, loop autoplay muted. On mobile browsers, you have to say muted, even if it is a silent video, for it to autoplay. That way, it doesn't, your browser doesn't get all loud when you're in a meeting and you're surfing the web. But video is always the last thing to download. And so this can actually delay the download of your video, even if it's really, really small. But in Safari, you can do really cool things like actually put the video inside your picture tag. And it'll actually, in Safari, this will load the MP4, which is really kind of cool. So if you built a picture tag like this, you have the MP4 for your Safari users, you have an animated WebP for your Chrome users, and then the GIF for everybody else. And the load time is crazy fast for your Safari users. It takes 4 seconds for it to download versus the animated GIF, which takes 22 seconds for it to download. So there are a lot of really awesome ways that you can optimize your GIF content so it gets downloaded quickly for your customers. So we've talked a little bit today about how we can optimize the content that gets you your images, how we can optimize the images so that they're delivered quickly to the mobile device. But wouldn't it be really, really cool if you could know what your customers want when it comes to the content on that you deliver? It actually exists. There are headers out there. On Chrome, you can say, I would like to save data. And then a header gets added to every single request that says, save data on. So now you have your customers actually telling you, hey, don't send me a giant image, send me something smaller. I don't want to waste all of that data. Send me smaller stuff. And there's research out there. So this, Tim, on his website, found that 50% of his users send the save data header. 10% of them have it turned on. So 5% of all of his users are saying, hey, don't send me all that data. Send me something smaller. So you can actually optimize your content for these users to send less data. So imagine if you have a news website, maybe you just cut out some of the images. There's no loss of the content here, right? All of the words are still here, but you've just removed some of the images. It's going to load faster, and you're respecting what your customers are saying. They're saying, hey, send me less data. You could actually lower the quality a little bit more. And so if I take the quality from auto to quality auto eco, which is it's a more aggressive compression, I can make these images still look really good, maybe a little lower quality, but I just saved another 50 kilobytes. So my customers are saying, hey, serve me a small image. Let's do it. If they're asking for that, let's serve them something small. That makes a lot of sense. Another thing that we can do to optimize the images is let's look at what their network is saying. There are a bunch of APIs that are out there that say, hey, what kind of connection are they on? What's the speed of their connection, right? If they're on a slow connection, right, serve them a smaller version of your file, right? Serve them, maybe don't serve them video, right? See what if they can't, it won't download in a reasonable amount of time, don't give it to them if it doesn't affect the quality of your site. And then finally, let's be vigilant. So you've built your site, you've now matched your competitors, right? You've sped it all up, but we're constantly adding new features. We're constantly adding more images. Be vigilant, because if we're not vigilant, we're going to slow back down again. And if we slow back down again, we're just making our customers angry again. So continue testing performance, monitor it with all of your testing, look to see if you're getting slower. If you're getting slower, try to figure out what made that slow down and see if you can optimize that away so that you can keep your site, you can keep your app running fast and efficiently. In summary, here are a bunch of the tools that I used: web page tests, the HTTP archive, some of the tools I used to optimize the different images that I showed in the presentation. And so, in conclusion, your images can be beautiful, they can be fast, you can deliver them quickly to give really fast experiences to your customers. So with that, I'd like to thank you very much for listening. I'd be happy to take any questions.
Friends, could I ask you to ask questions in English? Sorry.
You could ask in Russian, but I won't know what you asked.
Hi, I'm Pavel. Thanks for the talk.
Yeah.
And could you please recommend me something for rendering SVG animations equally good on both Android and iOS? Because now we are facing an issue with our animations. They kind of, like drawings, animated drawings. And right now we have to use MP4 format, which is not, really.
So you're looking inside a native.
Yeah, we are looking for something for rendering, like vector animations to decrease the amount of traffic.
I wish I had a good recommendation for you, but I don't have one for you. I'm sorry.
Oh.
But we can talk about it afterwards. Maybe we can come up with something.
Yeah, thanks. Let's do
Yeah,
this.
you bet.
Hi, Doug. Thanks for talk.
Thanks.
Yeah. Could you please recommend some tool for emulating the slow internet on a real Android device? Because I know it is available for emulator, but
Right.
for a real device,
Yeah.
I haven't found something.
Yeah, so the tools that I was talking about earlier, and let me just pop back here real quick. So when you use Charles proxy, it's a proxy through your computer, and you can actually slow down the connection on that proxy. So it actually does slow it down. Video Optimizer does the same thing. It's actually the proxy is on the device itself, so you're slowing down the network connection actually on the device. So these are actually using real devices that are connected. Video Optimizer, you can actually use it on a cellular connection and slow down the bit rate.
So it works on the transport layer, yeah, on the
Yes,
TCP.
correct. Yep.
Yeah. Thank you.
Yeah, you bet.
Hello, thanks for your speech. And I wanted to ask you, you presented us the comparison with the GIF format and the MP4 format in animating experience.
Right.
So, and do you have any experience in comparing WebP with GIF?
WebP with the
Yeah.
animated WebP with the GIF. I didn't talk about it, but it was on the slide. So let me fast forward here.
Yeah, but that was just one example. And do you have any other things, other? Yeah.
So I haven't done anything scientifically. There's not a lot of animated WebPs out there to look at. But in general, they are smaller.
Then GIF,
based on my sample set of like doing it 3 times.
Okay.
But from what I found is the animated WebPs generally are smaller than the animated GIF.
So, and you're in general thinking that the MP4 format will be the best for the web searching and the applications.
Yeah. So actually, if you go to if you're on like the Twitter application and it says GIF in the corner and it's animated, oftentimes it's not. They're lying to you. It's often not a GIF, it's actually a movie. When you click it to download it, they've got, on the back end, they know, oh, he actually wants to download the GIF, and they'll send you the GIF when you make the request to download it. But a lot of times on a lot of these applications, when it says GIF, it's actually an MP4, just because the delivery time and the compression, they're so much smaller.
Thanks a lot.
Yeah, you bet.
So, other questions?
Hello.
Hi.
My name is Alexander. Maybe you know about some tools for optimizing SVG files. We have some problem if SVG file is more detailed, you can expect
Right.
string overflow when you convert it.
So there are a bunch of tools to do that. I can't think of them off the top of my head, but a quick Google search will help you. I've seen presentations where they show those tools and they do optimize, because you can write out those vectors and you can have obviously optimization to make them compress a lot smaller. But I can't think of the name off the top of my head.
Okay, thank you.
Yeah, you bet.